Hey guys, welcome back. I'm your friend Pawan, and in this video we are going to learn about instruction set for the subject microcontrollers and embedded systems. So let's go and get on to it. Now, before beginning the instruction set, let's see what are embedded systems, because instruction set are those set of instructions which we use to run an embedded system. So an embedded system is a specialized computing system designed to perform a dedicated task. So this is very much like your function in your C program or Python program, which handles only a particular task. And these are normally built into devices to manage and control its operations. Example, washing machine and television. Now, you know how big the washing machine is, right? So to run that washing machine, we'll be just using a small green piece of board to run the all its functions. And it necessarily need not have an operating system to do so. Next, let's see what is an instruction set. These are sets of code which is written in machine language, which only a processor can understand and execute. Now, as a human, we speak many languages: Kannada, Hindi, Marathi, English. We have many languages, but the processor knows only a language called the machine language. An instruction set architecture is a fundamental for fast building and efficient computers, which has optimized memory and processing resources. Now, since the machines which we are going to use, like I said, a washing machine, we don't want it, like the board is very small, and we don't want it to, heat it up a lot, or we don't want it to use a lot of memory. And for that, we use a light code such as an instruction set code. Now we have various instruction sets representing various functions. So as you have various functions in your C program as well to do many particular different tasks. So same, we have many different functions to do many different tasks in an embedded system. Instructions are used in coding of ARM processors, which require assembly level language to code its processors. Now this is a hierarchy of programming languages. You can see that first to run anything you need a hardware. Without a hardware you can't run any software. Even this whole computer system, to run any specific task where you need a dedicated hardware for that. Next is opcode and operand. Now each assembly language is split into an opcode and an operand. Now let's see what are those. An opcode is an instruction which is executed by the CPU, whereas an operand is a data or memory location which is used to execute that instruction. Meaning the opcode is the instruction and operand is the location of the memory where that particular instruction is executed. Next are classes of instructions. We have many classes of instructions in microcontroller embedded systems, such as the data processing, branch instructions, load and store instructions, software interrupt instructions, as well as program status register instructions. But here we are going to learn only about two, that is the data processing instructions and the load store instructions. Now let's see data processing instructions. These are the very fundamental arithmetic and logical operations of the processor and operates on values in general purpose registers or a particular register of an intermediate value. Meaning this is just like your CPU's or that ALU part. So it is very much similar to that. And the data processing instructions mostly use one destination register and two source operands. So it's like your addition of your two numbers, like C equal to A plus B, where C here is the destination register and A and B is your source operands, like where on what are you going to perform the operation on. Next is that the data processing operations include many, such as the move function, logical instructions, arithmetic instructions, multiplication instructions, and comparison instructions. The move instruction, which is the simplest ARM instruction, it copies a n value into the destination register RD. and where n is the register or an intermediate value, and it is used to initialize a value or transfer data between registers. Now this is very similar to your, that initialization function equal to, where you give the value of your, let's say, a 5 number to a variable, like it moves the value to that variable, right? So it's very similar to that. Here we have mov and mvn instruction, and in mov it uses a 32-bit value into a register. Here we have an example of how it works. Let us take R5, register 5. Like if we have multiple registers, we'll be using register naming as R1, R2, R3, etc. Now R5 is 5 and R7 is 8. If I use the function mov and use R7, R5, we let the computer know that R7 is equal to R5, meaning the R5 value will go to R7. Next is the arithmetic instruction. It is used to carry out addition and subtraction of 32 signed and unsigned values. We have various instructions, but the only two main thing is the add function and the subtraction sub function. Now the ADD is to use add of two 32-bit values, whereas we use sub to subtract two 32-bit values. But when you use a C in front of the AD or SU, like SUB or ADC, you mean it to add the values and have a carry. Like sometimes that there is a small carry left over, right? So it carries that value. And next is, we'll see logical instructions. It is the bitwise logical operations which are performed in this instruction. The AND, capital AND, says as the logical bitwise AND of 32-bit values. A point to note that is, in these embedded systems, we are majorly dealing with all 32-bit values. Next is the OR, which is the logical bitwise OR, and EOR, which is your exclusive OR function. Now BIC is a function but we don't use it much. Next are comparison instructions. These are used to compare and test a particular register, and these registers does only the comparison and updation of CPSR register. Now CPSR is a register which, like, we don't have any values for that, we won't store any values, we won't edit any values, but it is used to raise a flag. But the value will not change, only a flag will be raised. These four will be only using the CMP, which is your comparison operation. It is very similar to your if part, like if part of a program. Next is multiply instructions. This is used to multiply the contents of a pair of register. Now we use MUL function to multiply any values. Next are load and store instructions. These are used to transfer data between memory and processor registers. There are mainly three types: single register transfer, multi-register transfer, and swap. And example here, LDR, which we'll be using the most. It is used to load a word into a register. Next is an introduction to Keel Microvision. Keel Microvision is a software where you can perform your embedded system calculations. Like I just showed you all the instruction before. This instruction you can use in the software to run the software and to execute a program. So this is just like your normal program. It will be very easy, just it will be used in an assembly level language. Now about the software, it is a software development tool which is used to write and debug code for microcontrollers. And Keel MDK is the complete software development environment for a range of ARM Cortex-M based microcontrollers devices. For doing any, for beginner level execution, we'll be using processors for doing it, which are already embedded into the software itself, but we'll be mostly using LPC2148. Now, why is that? We'll be using LPC2148 because it is a 32-bit processor based on risk. Now, if you have learned about risk analysis, you know what are the difference, how, which is complex, which is not complex. And because we need to use all the things which we are using, like less memory, less time, less everything. Now, because it also suits perfectly for beginners to get in-depth idea about the hardware and software implementation. This is a code which will be using in your Keel compiler, and this is the code which finds the sum of first 10 integer numbers, and this is the output how you get. Now, as you can see in the screen, this is how the editor window of the Keel compiler looks like. Get your values in the register column, where you can see some register values have changed, and that are your answers. And yes, this is the end of the video. I hope you liked my video, and you can comment your thoughts in the comment section below. Thank you for watching.